Okay, now we're at part 2. Now the next bit is very important. We are going to record what species of phosphorus our standard is made up in, or what species of phosphorus we have in units of milligrams per liter. When we follow the instructions in the FIA manual, it tells us how to make phosphorus standard or nitrogen standard in elemental nitrogen or elemental phosphorus milligrams per liter. So we want to indicate that and make a record of it, that these peak areas and these concentrations were determined based on elemental phosphorus in units of milligrams per liter. And of course, as soon as I make that record, I'm going to save my work. We'll scroll down a little bit, and here are the standards, the number or the injection. We made 3 injections of our 0 part per million standard. That was in cup number 76 and had a known concentration of 0 milligrams per liter. We made 1, 2, 3 injections of our 0.5 part per million standard in tube number 77 with a known concentration of 0.5 milligrams per liter. So let's take those milligram per liter values. Let's take our peak area values, and we're simply going to copy and paste them off to the side. We always use the 0 part per million standard as if it were any other standard. So this 0 part per million standard and its absorbance value will be an X value and a Y value that goes into our correlation calculation, that goes into our slope calculation, and that goes into our intercept calculation. So let's think about that for a moment. So let's calculate the slope of our calibration line. Equals slope. We enter the known Y values, which are, of course, the peak areas. Always put your peak areas on your Y axis when doing any kind of analytical chemistry. And then we enter our X-axis, which is the units in milligrams per liter. And that always goes, those concentration values always go on our X-axis. Now you'll note that we do have the 0 part per million standard included in this slope. Then let's do the intercept. Again, there's a function in Excel that does this. Intercept. We enter our Y values. No, I do not want help. Thank you. We enter our Y values or our peak area values, comma, and our X-axis or known concentration values. And again, we are using the 0 part per million standard in this calculation. Let's have a look at just how good our XY correlation is by running a correlation coefficient. So we'll look at the peak areas, comma, and we'll look at the known concentrations that gave us these peak areas. And 98%, I have a feeling we could do better. Now, what I like to do here at this point is I want to look at the actual correlation line. So let's highlight the X and Y values. Let's insert a chart, an XY scatter chart. And you can see that for the most part, we get a nice straight line, but things begin to come out of linearity when we get to the 30 part per million standard. So we could probably safely eliminate that 30 part per million standard. So let's see what happens when we remove that 30 part per million standard from our XY plot, and it looks nice and straight. So let's see what happens when we remove that 30 part per million standard from our correlation. And we notice right away that the correlation goes up to 99.8. Not bad. I wonder if we could remove the 15 from our correlation as well. Let's have a look at that, see what happens. 15. Whoa, and it goes up to 99.98%. I think that's pretty good. So we're not going to use our 15 part per million and 30 part per million standards. Let's just erase those numbers. Do our slope. And so, and do our y-intercept. And we get a nice straight calibration line. We get a very good correlation coefficient, and we get an intercept that is very, very close to 0. We are well on our way.